Hey everyone, we got a nice easy problem here. We're looking at a graph, and the first thing we're asked for is to find some limits. So the first limit here is x approaches -3. So we look at our graph, we find x equals -3, so that will be this point here, and from the left side it looks like this is approaching 0. The y values are getting bigger until they approach 0, and on the left side we have a little bump here, but they are going to also be approaching 0. So again, the limit from the left equals the limit from the right, so this would be 0. Next we're looking at the limit as x approaches 1 from the left, and so we go to our x equals 1 line, and from the left it looks like it's approaching y equals 6. From the right, these y values are getting smaller, and they're also approaching 6. So the limit from the left equals the limit from the right, so the limit as x approaches 1 is 6. So next we're asked to identify the features of the function. So this first one says the equation of any vertical asymptote. So remember, vertical asymptote is anywhere where the graph can't exist, and that's anywhere that we're dividing by 0. So if you look at this function, we can actually get rid of x minus 1 because it's in both the numerator and the denominator. So the denominator would equal 0 when x equals -1. So that would be a vertical asymptote. So we can write here the equation is x equals -1. Equation of any horizontal or oblique asymptotes. So to find this, you will have to do some math here. You're going to have to do some synthetic division. So our first step would be to simplify this. So we have x plus 2 times x plus 3 over x plus 1. And so that would be x squared plus 5x plus 6 over x plus 1. And so we have to do some synthetic division. So if you're not sure what that is, just look up some videos and get yourself familiar with that. First step is we're taking this constant here, 1, and we're going to turn that negative. So we'll put that up here. So next we're going to list out the constants. So for this term, this would be 1. This term is 5. And then the last term is 6. So we bring this one down, and then we multiply 1 times -1, and we put that here. And now we're adding this. 5 plus -1 would be 4. And we take 4, multiply it times -1, we get -4. And we add 6 plus -4, and we get 2. So this is going to tell us the constants for what x squared plus 5x plus 6 divided by x plus 1 is. So that would be, this would be an x plus 4, and this would be our remainder. The 2 would be our remainder, so we'll have 2 over x plus 1. So the equation for the horizontal or oblique asymptote is this part here, x plus 4. Okay, so the next one is really easy, the coordinate pair of the y-intercept. So that is right here, and that would be 0, 6. And then it's the coordinate pair of any zeros. So that's wherever y equals 0, and so that's these 2 points here. X equals -3, y equals 0, and -2, 0. Alright, number 2, we're drawing a graph based on the function that we're given. First thing I like to do is simplify this. So we'll start by factoring. We'll have x plus 4 times x plus 1. The numerator, we'll have x minus 2 times x plus 1 in the denominator. And as you can see, this x plus 1 cancels out because there's 1 in the numerator and the denominator. So our simplified equation is x plus 4 over x minus 2. So first thing we can do is we can see that there's going to be an asymptote at x equals 2, since if we plug in 2 in the denominator, that will equal 0, and so we can mark our asymptote here. Next we can find where the equation will equal 0, and that's wherever the numerator equals 0, so x plus 4. So at x equals -4, the numerator will equal 0, so we can plot that on our number line. It's -4, and we can also make a point here at -4, 0. So now that we have that, we can test where these values are going to be negative and positive. So to do that, we have -4s are 0, so we can test the left side of -4. We can do a of -5, and we'll get -5 plus 4 over -5 minus 2, which equals a -1 over a -7, and that's going to give us a positive, really small number. So everything to the left of -4 is going to be positive. And then we can test everything to the right of -4. So we can do a of 0, and that will be 0 plus 4 over 0 minus 2, and we'll get 4 over -2, which is a -2. And so we can plot that out here. That's 0, -2. And then we can connect these dots, and the graph will go down like that, never actually having a y value at x equals 2. Okay, and then to get the rest of this picture, you can just graph out some points where x is greater than 2, and you'll get something that looks like this. Next is b of x. We have x plus 2 squared times x plus 4 over x plus 4. This one's really nice because this x plus 4 in the denominator and the numerator cancel out, and we're left with x plus 2 squared. And if we follow this out, we have x squared plus 4x plus 4. So this is just going to be a parabola. So to graph this, we can just do find out where where y is going to be 0. So that's going to be where x equals -2. And because this is a positive x squared, then all the points are going to be positive at all times, so it's going to look something like that.